So I would like to continue with where I left. So there was one last segment that was left, the subnetting, right?
Yes.
So let me just give you. You are able to see my white screen, right?
Yeah. Yes.
Hello. Yeah. So in production, right, most of the time what would happen is, nobody is going to give you a subnet and ask you to tell you what is the network broadcast and what is the usable opportunity. So in production, what kind of scenario that you would encounter is, so you would be coming across some IP address where you would need to find out what subnet it belongs to. I mean, what is the network address broadcast itself? It would be reverse. So initially we would have the subnet like 192.168.1.0/24, and then we will just do all the calculation and just divide them, scramble them into different parts, right? But in protection, you would get some IP address here, right? Where you would be in a position to find out what would be the network address, whether I'm working with the right subnet or the wrong subnet, right? So they would just give you this IP address, and you would have to find out what is the subnet for this and how many hosts are there using the subnet mask. So they will give something like this: 182.168.1.15/24. This is how you would get. So using these two values, you would need to find out what is the subnet, what is the network ID, what is the broadcast ID, and what are all the usable range. Do you think we will be able to find out?
Without the slash, how can we find it?
They, you have these two information.
Yeah, with this two information we can find it.
You can find out.
Yeah. Network ID part is
Okay.
the first three thing.
Find out. Yeah. Find out for this dash 100.
Yeah. So network ID part is 24, 24, 26, 27, 28.
No, no, here. You forget about this.
Yeah.
You forget about this. Yes. Yes.
Okay.
Use this.
Yes. Slash 28 means network ID part. Uh, um, First 4 bits of the last octet, 24, 25, 26, 27, 28. Till that time it is network ID. So 92.168.1.18/28. Now network ID part. So say this is class C network. In class C network, if it is slash 24 by default, then first 3 octets are network ID part. Since
Mm-hmm.
this is slash 28, that means
Mm-hmm.
that apart from the 3 octets as well, in the
Hmm.
fourth octet, four MSB bits starting from MSB1, MSB2, MSB3, MSB4 are also part of network ID. Okay.
Mm-hmm.
Yeah, if it is dot 18, then um, 128, 64, 16, 20, 9, 10, 14. Is it 192.168.1.240, the network ID part? Sorry, I kept joining and rejoining. I think I can hear you now. Hello? Yeah.
We have the subnet mask, right? /28.
Yes.
Correct. So you forget about this for time being. Okay. I don't focus much on here. Just focus on this. 28. So 32 minus 28 is 4. 2 power 4 is 16 host. Correct.
Yes.
So what it tells? It tells each subnet can give me 16 hosts.
Yes.
Correct. And then first one goes to network ID. Correct.
Yes.
And the last one goes to
Broadcasting.
broadcast. And then the next subnet starts. Correct. From 17 network, and then another 16. Correct.
Okay.
Correct. So my first subnet when I'm using /28 would be 192.168.1.0. Correct. And it ends at 192.168.1.15. Correct.
Yeah.
Because 16, 2 power 4 is 16. So it starts from 1.0 and ends at 15. And then the next one starts 192.168. 1.0 slash, sorry, not 1.0, it is 1.16. 1.16 slash 28, and then it goes on until 31, right?
Yeah.
Slash 28. So like this, it will go on until it hits 192.168.1.255. Correct?
Yes.
So in this, so we made /24 into /28 small subnets, right? So we have reduced, or we have divided the network into /28. So it means +4, correct? From 24 to 28 is +4, correct?
Yes.
So the increment in the subnet mask from 24 to 28 gives you 2 power 4. So it means you can have 16 subnets. You don't have to count like 1.0, 1.16, 1.32, 1.64, you know. So you don't have to write down all the ranges and then count one by one. So using the subnet mask itself, you can identify how many such subnets are possible. So 28 minus your old subnet gives you 24, sorry 4, right? So it means you have 16 subnets. Clear?
Yeah.
To find the host, you will minus 32 minus subnet mask. Okay. To find the networks, how many such networks are possible, you will minus /28 with /24. Clear? Let's do the same math for /27. Okay. So for 27, I'll give 24 minus, sorry, 27 minus 24, right? It will give me 3. So it's possible that 2 power 3, 8 subnets. Okay. Same for /21. How many hosts are possible in each subnet is 32 minus 27. That gives 5. So 2 power 5, 32.
32.
correct?
Yeah.
Okay, let's just give one more try. One 168. Okay. Mm, 14/29. Okay. Give me the network address, broadcast address for this subnet.
So 32 minus 29 is 3.
Hmm.
Right. So 2 power 3, we have 8 hosts.
Okay,
Each
8 hosts.
each subnet will have 8 hosts then.
Correct.
Yeah. So starting from 192.168.1.0,
Hmm.
yeah, up till 7.
Okay. So this is not the subnet that this guy is going to follow.
Yeah. So basically,
Okay,
when
what
we
is it?
wrote that number 192.168.1.14/29, the
Hmm.
question we are asking is, in which subnet does this IP address fall? Is that the
Correct.
question we are asking?
Correct. So in production, this is how you deal the problem with subnet. Containing some IP address, you would go in the reverse way. We have learned it in the forward way, right? From top to bottom. But so top to bottom means what? From building stage to the final construction, correct? Top to bottom. So in production, what you'll have, you will already have something which is already constructed, right? You are not going to construct and build from starting. So when you're looking at the finished product, you should know from where it came from. So that's how it starts. Like you would be looking at an interface IP address 1.14/29, but you should know what is the network address and broadcast address just by looking at this.
Okay.
Okay, you will understand more when we do Cisco packet tracer. So have you downloaded the application?
No, actually, I'm not getting enough time after work, so just getting
That's
ready
okay.
for.
Just see if you are able to get some time this week. Okay, we
Okay.
will start the lab mostly from the next week.
Okay.
I think with time permits, we will start this week. Otherwise, it will start. But tomorrow, I'm not available in the morning. So tomorrow, I'm leaving early for some personal work.
Okay.
And then we'll have classes on Thursday evening and your Friday evening.
Okay.
Okay.
Yeah.
So okay, let's finish this. So you gave the first subnet, and what is the network ID of this IP address?
Yeah. So, um, and then the next subnet starts from 192.168.1.8.
Correct.
Yeah, it goes on till 1.15/29.
So
So
this guy falls in this range, right? So that's what. So what would happen is, I'll just give you a small brief, okay? So you'll have two routers, okay? And there is one more router. Very common stuff. So what you will have is 192.168. Let me erase this. So you will have to configure an IP address here, okay? So they would say like take this subnet 192.168.1.0. So this is what basically usually people will take when it comes to take an IP address. Okay. In one end you will configure /24, right? Let's say you have configured 1.1. In another end you will configure something else. 192.168.1.5/30.
mm-hmm.
Right. So when you look at this from this guy, 1.1, 1.5 falls in the same range, correct?
Yeah.
1.1, 1.5 is the same subnet. But when you look at this guy, right, the starting range itself 1.4, and then it's into 1.7. So 1.1 does not fall within his range.
Okay.
Clear?
How does 1.1 fall in the range of 1.5 going to the earlier point?
Slash 24. Slash 24.
Yeah, that is slash 30.
This is slash 30. So this IP address won't fall. Sorry, this 1.1 won't fall in 1.5.
Yes, they are separate.
Correct. But when you look at from this perspective, slash 24, 1.5 fall in here, right? For him, he is included in his network. For him, he is not included in his network.
Yes.
Correct. So what would happen is, most of the time you won't have in a production network. It might be some ISP site where you won't have awareness about how they have configured, right? So you would be sitting at the customer edge. So in your network, so you would say like I configured 1.1. What did you configure? He would say like I configured 1.5. Simply you would say, since you have slash 24 on your end, right? So you would think like, oh, 1.5 falls in my range, then why it's not coming up? So the port interfaces won't come up if you have mismatched subnet configuration, right? So you would be struggling like why it's happening like that. I have 1.1, 1.5 all in the same range. I have configured slash 24, and the interfaces are not coming up or the IP connection is not getting established, right? So that's when you go and ask your ISP, did you configure slash 24 or something else? Then he would say, no, no, no. We as ISP we always configure slash 30. We never do slash 24.
Okay.
So that's the awareness you should have when it comes to IP address subnetting and configuring all these things in the production network. So even if you go 10 years in future, these issues still would happen because I have seen this issue on my first month of the job. I'm still seeing this issue where the ISP is playing with the subnet value even after 10, 11 years.
Okay.
So you should have this. This is just like a day-to-day operational task where you need to be like very strong. These are like basic stuff. Okay, you need to be strong. So it should come directly, or even if you put your issues in Google or any AI chatbots, this would be one of your checklists. If when you see the link between my ISP and my customer edge router not coming up, and the connection are getting established, this will be one of your checklists.
Okay.
Okay. Okay, so we are done with the subnetting part. So if you have any questions, you can bring up in later sessions. But topic wise, we are going to move forward.
Okay.
Okay.
Yeah, a bit difficult topic.
Yeah, this should be like little, but other things are okay. Like a little bit of theory. This is completely max and little focused. So the chances of committing error and logically wrong so many times happens
Okay.
with subnetting, but other topics are okay. So
Okay.
they have some basic knowledge that should be okay.
Yeah. Can you zoom in your whiteboard? Actually, I'm seeing lot of gray. If you can just
Oh, no.
zoom
Okay,
in.
okay, okay.
Yeah, I think
Now,
now it's fine. Yeah.
hmm.
Thank you.
So next thing is, I think I gave a brief about this in our previous session, but yeah. So let me. So this is the next part in the CCNA syllabus, which is talking about network topology architectures, type of architectures, where it is used. So you cannot simply have a router, switch, PC in everywhere, right? So depending upon the size of your network, depending upon the number of users, you may have to uh, choose one architecture type. So when someone calls you, what is your architecture type? What is your network topology looks like? So instead of explaining them each and everything, it usually looks like this kind. You give a name and you tell them it is usually like this. Since it's my office network, since it's my data center network. Okay. So let's go with the network topologies. Okay, one by one. Network topology architecture. Okay. So first one is two tier, three tier, spine leaf, WAN, small office, home office. Okay, it is something like this: small office or home office. Next one is cloud, on-premise, and cloud. Cloud means you know, right? AWS. Okay, so let's. I think I have explained you about these two architecture, three tier. If I heard the word core distribution access layer, I think I explained this in our first or second class. Just gave a glimpse of it. So mostly, right, this is on the pure LAN side, local area network. Okay. So although you have multiple this is about architecture. How? So consider you have an office, right? So in your office, if you are going to office, have you noticed the server room?
Yes.
There will be a room called server room. So where you will have routers,
Yes. Switches.
switches, some
Even
servers.
firewall.
Exactly. So firewall. So all
Modem.
these things. So if you see, right, they will be stacked on a rack, right? They won't be kept on the shelves like that.
Yes.
So there will be racks. They'll be kept one by one, like from top to bottom, right? So they are organized in this fashion. Any one of these two, either they will be in a two-tier model or three-tier model or spine leaf. Spine leaf is a data center, so that spans across more than one room. Spine leaf, but two-tier, three-tier is mostly suitable for rack kind of an. Rack means you'll have rack shelves. So on each shelf you will have routers, switches, on this one of this architecture. So connectivity will be like this. Okay. So when we are discussing about let me when we are discussing about two tier and three-tier, right? So we are talking about. So when I say two-tier means what are those tiers, right? So basically there are three layers: core layer, distribution layer, access layer. So when I say two layer, it's going to be these two tier. When you are going for a three-tier, then it's going to include these three layers. Okay. So what will come in when I say two layer? What will come in the access layer? So access layer mostly will have your end devices, end host, printers, phones, and PCs. In distribution layer, you'll have access switches, switches basically, switches and routers. Okay. When you are going for a core layer, again the same explanation falls in for the access layer, right? And then you use firewall, your uh, let's add the server also. So you will have firewall, you will have proxy, you will have routers, you will have switches. So all the decision making stuff, right? So you don't give so much of load on the core layer. So that is going to handle a lot of traffic. So you're not going to utilize the CPU of the core layer for decision making. Right? So all the decisions are made, like whether to allow the traffic, whether to send the traffic out or receive the traffic, NAT policies. All these things would be kept at the distribution layer, right? Security. Okay. Access port, router, access switches. Generally, you can say switching. Okay. So all these devices, belonging to routing, switching, security are distributed in the distribution layer. On the top layer, you will have very high-end devices or high-end switches that sends your traffic out of the network and hand the traffic over to the ISP. Okay. So mostly it will have devices like Nexus switches. When you go to Cisco's model, you'll have Nexus switches. They are like very powerful switches that can uh, send traffic with the 10 gig interfaces. The interface capacity itself would be like 10 gig. Okay. So this core layer would help in connecting multiple distribution layers. So when I said how it's going to handle a lot of traffic is the traffic will go here and then it will connect multiple distribution layers. So consider you have two buildings, right? So the core layer sits here, that takes traffic from distribution layer and helps it connect to distribution. This is distribution, this is distribution, this is your access, and this is your access. DID. Okay. So by connecting multiple distribution layers switches, the core layer is going to responsible to handle so much traffic. So that's why we put the burden of filtering the traffic by adding security policies or sending the traffic using the best route in the routing table. All this will be taken care by the distribution layer switches or routers, and it will be forwarded to the core layer devices. Since it's going to handle a lot of traffic coming from multiple distribution, so it's not going to spend time on CPU cycles in making all those decisions whether to allow or filter the traffic, right? So this is a three-layer architecture. Let me, any questions here? These are basic topology architecture depending upon your office network.
Okay. So basically, distribution layer is having devices which accept and forward packets, and access layers are the endpoint host mostly, and core
Yeah.
layer is
So
connecting different networks.
so access layer is going to accept the traffic from your LAN. Okay. Access layer, and it will forward it to the distribution layer where the decision making happens. Decision making in the distribution layer. Okay. And once the decision is made, it is sent to the core layer where it's just going to follow the decision made by the distribution layer switches to send the traffic between multiple distribution layers.
Okay.
Right? For example, you'll have servers, right? Same building, let's say you have servers here, right? So it say like I know I would like to go to this distribution. So you may create policies in the distribution. Say okay, you allow whenever a traffic comes from this server, send it to this core switch and receive it here, right? So the decision is made by the distribution layer. So to send the traffic to this next switch. So when what this core switch will do, whenever a traffic comes here, it will simply forward it to this guy. So his work is mostly focused on just fast switching, just sending the data as fast as just transfer the data as fast as it can. So it's not going to check okay what is inside, okay whether they are sending HTTP traffic or FTP traffic. Should I allow HTTP? So he's not going to spend time on verifying what is allowed or what is not. You take care of all this decision making process, to sending whom to whom, filtering whom to what, right? Then you send the traffic. I will blindly forward it to somebody else.
Okay.
I will not spend time here. Okay. And then we have spine leaf architecture. So spine leaf architecture is very much meant for data centers. Okay. So let's just draw a small diagram. Spine 1, spine 2, leaf 1, leaf 2, leaf 3. Okay. So when I say leaf 1, leaf 2, they are all like switches only. Okay. And then you have servers. Spine is also a server. Sorry, spine is also a switch, but it is more powerful than the leaves server. I would tell you why it is more powerful. 1, 2, 3. Okay, what happens is in spine leaf architecture, every leaf connects to a spine.
Oh, what is leaf here?
Switch.
Okay.
I told you, right? Tier 2, tier 3, spine leaf, they are all representing LAN. Right? When it comes to LAN, the most widely used networking device is switch. Okay, so this is switch. This is also a switch, probably a higher end switch to handle high capacity data. Okay, so your leaf, right? Leaf is also a powerful switch. That is just sitting ahead of your server. Earlier we have seen in the 2 tier, 3 tier model, printers, PCs, right? Small end host. Correct. The spine leaf architecture is meant for data center network where you would see servers. Okay.
Hmm.
So you would see each leaf connects to each spine like this. Clear?
Yeah.
But there won't be direct connectivity with you. So you don't have this connectivity. It's not there. So leaves do not connect to each other. They will connect to the spines. Okay, this is the spine leaf architecture. So there is one concept called full mesh. Okay. Full mesh means consider you have this kind of a setup, 4 devices. Okay. So every device connects to every other device. Clear?
Yeah.
So this is full mesh, right? But if you compare it with spine leaf, right, it is not a full mesh. Correct? Leaves do not connect to each other, but every leaf is connected to the spine. So that's what you need to understand from this diagram. So in most of the networks, right, just for easier deployment, they will go with full mesh. When it's going to be a partial mesh or some devices not going to connect with some other devices and few devices wants to connect with only few from among the other devices, that's when as a network administrator you will face a lot of challenges in creating policies, right, to avoid some devices not connect with others. When it's going to be a full mesh, life is easy. So you simply go and deploy what is generally designed in book, whatever is written in book, and it's going to be full mesh. So when it's going to be partial mesh, spine leaf architecture, and other architectures like hub and spoke, right? That's when you are going to squeeze your mind and bring out some ideas to see what is best suited for your company as an architecture. When as an architect, you would be working on implementing designs and understanding what is best suited for your. Clear?
Yeah.
The next one is WAN.
Yeah, but what is the point of having architecture wherein the leaves are getting connected to the spine and then the spine is getting connected to something else?
So the reason here is again to once again let me bring up spine.
If you do Control Z, you'll get it. Control Z. Yeah.
See, here you have servers, right? So leaf is meant to handle only the traffic from this server. Okay, server is a highly loaded device, correct? Server one, server three. Server is going to have some information that will be requested by millions of users across the world, correct? So we will have a leaf layer, right? So you have spine and leaf. So why don't we have, no, let's connect a server, let's connect a switch, and let's connect a router, right? And then what is the problem in sending the traffic? Why are you having so many spines, so many leaves? That's your question, correct? Why don't you make it simple?
Yes.
So server connects to, you dedicate one switch specifically for the server.
Okay.
Similarly here, at the leaf layer, right? You serve it, you act like an immediate assistant. Okay. And then once the traffic hits the leaf should have two paths at least, as per this diagram. You will have many paths. I have seen 8 paths, 16 paths, above the leaf layer in my in our data center networks and that. Just in this diagram, I'm just giving an example like two spines. Even if this path goes down, the leaf should be able to send the traffic seamlessly towards this spine. So if you keep this diagram, right? So if you keep this setup, if any connection breaks, your whole server will become unreachable, right? So from the leaf, you will have multiple spine. So that's why the leaf is connected to multiple spine to give high redundancy. Redundant setup. Like you have a seamless connectivity even if any one of the path breaks, which is usually taken by the leaf towards the spine. So from the spine, so consider why we have a spine with more powerful devices, because server 1's traffic, server 2's traffic, server 3's traffic can go to any spine, right? Because every leaf is connected to every other spine. So the spine is capable of taking high amount of traffic than the leaf structure, and also it can offer setup, highly redundant setup. Redundant in the sense failure proof.
Okay.
Okay. Okay. Let's go to WAN. So WAN is something like this: router, um, switch, router switch, PCs, switch, PC, internet, or MPLS. Okay. So this setup is WAN. Connecting, it could be LAN 1, right? LAN 1. let's say Mumbai office, LAN to, let's say somewhere like New York, New York office. So it connects multiple LANs across the continent, across the countries over the wide area network connectivity. So typically, the latency in the WAN networks are pretty much higher, like 50 times, 60 times higher than latency in the sense the time taken to connect to host, right? So if you're in the LAN, right? So you just need a switch. You don't need a router here. So this is how. In the LAN, you connect two devices, right? So the time taken to send data, it might be milliseconds, 1 millisecond, 2 milliseconds, nothing more than milliseconds. Okay. But in WAN, right, it might take 100 milliseconds. 200. When you are going out of the country, it will be more than 200. And if you are going for some developing countries like Africa, you will have minimum 300 plus latency. If you're connecting from India or US to Africa country network, right? The latency would be like 300 plus milliseconds. If you're going from India to UK, right? It would be around 100 to 200 milliseconds. That is the average latency expected. And if you're using satellite links, so what happens sometimes the WAN network, right? You know the ships, the, the ships which are cruise ships, example, right? They'll be taking the users, they'll be taking the people on a trip for like 1 week, 2 weeks. They'll be on the sea for like long time, right?
Yes.
So their network, right? So they cannot have a router. So for router you should be connected, right? So you have an ISP, right? ISP sitting at the shore. So he'll be giving you physical connectivity if it's an office setup, right? So they will have direct physical cables. But cruise ship is not like that. Cruise ship, if it is this region, so cruise ship will be, docking here in the morning, right? And then in the evening it will be here, and then in the night it will be here, right? So it will be keep moving. So you can't have a constant like broadband connectivity, right, in an office setup. So what they'll do is they'll connect to the satellite. So Starlink, right? Satellite-based WAN connectivity. So they will use Starlink kind of satellite-based connectivity. So satellite-based connectivity, the latency would be like around 600 plus. This is the minimum, or
Yeah.
this is the fastest connectivity that you can get from the satellite. Otherwise, to the downhill, you can go up until 1200 plus milliseconds.
Okay. This is like Starlink, right? One of the Elon Musk companies.
Correct, correct. One of the Elon Musk companies. So the problem here is the advantage here is you can use this satellite-based connectivity from anywhere in the world. You can go to mountains, you can go to in-depth ocean, you can go to any desert, right? You can always have satellite connectivity, but it will be very poor. You won't you can't expect speed. So if you just open a page, it may take more than 10 seconds, which usually opens up within a second in a normal office setup or a normal home connectivity. So satellite links are used in places where you cannot avail the normal internet uh, framework like MPLS or broadband or SD-WAN, right? So these are all like normal broadband normal internet connectivity, WAN connectivity suitable for a static place like office, home, data center. You can use this. But when it comes to ships, right? Cruise ships and you will have cargo ships, right? They are all use satellite-based connectivity. Here it is. You can replace this word internet with satellite. Earlier, see, before Starlink was also you had this before Starlink also you had a satellite-based connectivity, but Starlink made it popular. So they started. I mean, launching a satellite, right? It's very costly. right? Keeping a modem at your house to bring internet connectivity, it may not cost you more than $100, but launching a satellite will have to, it may cost you $100 million, right? But what you are going to get in return, right? Every investment needs a return. So when you're launching a satellite for internet connectivity, then you have to charge more. But how many people would come forward to avail such satellite connectivity when they can avail $10 broadband connectivity at home, right? So
Yes.
only very limited number of users. So that's why it wasn't that much popular, but it is provided on demand basis. But since Starlink came, so Elon Musk launched satellite after satellite, with a huge investment. So to make internet possible at every corner of this world. So that's why now the satellite-based connectivity is little popular. But still, you can't expect a good speed even with Starlink. It is so. What enterprises now they are doing is they are using this SD-WAN based WAN connectivity, right? So they will get one MPLS link that is very good perform that offer you very good performance, and then broadband moderate performance, right? And then they go with Starlink, satellite link. Why? Because these guys they can go down anytime, right? There is a high probability. We can say like not high probability. We can say like there is a good probability both of them can go down at the same time, right? So you have this. Let's say when I say go down, I'll just so you have one router. Okay, one is one. So you have switch, and you have PC, right? So this is MPLS link, this is internet link, and this is satellite link, which is Starlink satellite, right? So these are like physical connectivity cable, right? So they can go down at the same time in a rare case scenario, right? So if you do not have satellite link and you have only MPLS and broadband internet link, if both of them go down, you are completely lost. Your network is isolated, right? So after the adventure of Starlink, right now customers started using one of the satellite link is tertiary link. Tertiary means third link. It will be very slow, but at least it won't go down. It will go down only when the satellite breaks down. As long as the satellite is circling in the space, you will have the internet connectivity. Unless the satellite is completely explodes, just goes out of control. Okay.
Okay. So is it part of the so where is it located? Tertiary?
So they'll have some modules to connect. So how your satellite phones work, right? Same, you will have one module on this router that would help establish satellite-based connectivity based on the frequency settings that you frequency some settings you have. It won't be like a normal WAN broadband connectivity. You'll have a separate device. So you would connect to one of antenna kind of device. So similar to modem at your home, but it will look different. So you connect your router to that satellite's local device, and that device that help you connect you to the respective satellite.
Okay.
So with normal MPLS, right, you would be able to see physical connectivity like this customer edge ISP device, and then you would see some physical cable going out. But with a satellite device, you would have your customer device, and then you will have a satellite device with antennas, peeping out, and then you would see any connection hereafter. So that device will just stream the connection establishment towards the satellite. At the end of the day, you would still have physical connectivity with you. So you need to check the ports, make sure the connectivity, the ports, everything is configured as per the standard.
Okay.
Okay. So let's see this two arc because it won't take much time. So small office setup, router, switch, device, right? For redundant setup, small office, you may have two switches. You connect. Similarly, these two devices can connect to any one of them, or it can directly connect to this. So these two switches will connect to the router.
Usually one device will connect to one router, right? Even in small office, home office.
What happens is there is one protocol called VRRP. Okay. So you'll have small office setup, mostly one router only. I have seen in my experience. In my earlier stages, uh, I had seen customers always using two tier, like two tier in the sense a dual setup. They'll have two routers, two switches, right? So these guys will connect to any one of the switches. So if any one switch goes down, it will forward the traffic to the other switch, and the same is the case with the router. So they'll have some protocol enabled, so that if any one of the path goes down, they'll send the traffic towards this guy, right? So, but now I've like predominantly seeing it's like very small offices. This is the setup. I don't know. They are not spending much, or they're not worried about the high availability. But this is how it is. User machines, they'll have a lot of user machines. They probably have multiple switches in the bottom, but they'll have only one router, one WAN link. So at least in some sites in the previous experience, they'll have two WAN links. They'll give at least redundancy on the WAN link concepts. I'll have one router, but I'll terminate two WAN links. So if one WAN link goes down, the other one will be able to give me guarantee. But in some places, I don't even see this. So very small office like stores, right? Supermarket stores. So they have this just connectivity WAN and router and one switch, and then number of users connecting to this standalone. We call it a standalone setup. Standalone setup. So like this. So this is one of the small office or home office networks. Okay. So the last one is cloud or on-premises. So cloud or on-premises, they will leverage spine leaf architecture. Okay. So cloud in the sense, I'm talking about AWS, Azure cloud. They are like public clouds where you have to host your services in their clouds. Like you can host, even you can build up a router there, you can build up a server, you can build up a load balancer, you can invite traffic to the cloud. On-premise in the sense, you maintain all the devices in your network. So mostly if you are a service provider, right? So you call yourself Azure. So here, when you say cloud, you go and host something on the cloud, AWS, Azure, Oracle, Google Cloud. On-premise in the sense, instead of going to AWS, Azure, you maintain all the servers, firewalls, gateways, proxy servers, load balancers, everything in your data center. You own the data center yourself. You have a big data center. So companies, this petrol companies, bank, finance related companies, they have a lot of monies. So mostly they won't go with the public providers. They will have their own premises. They'll distribute it. 50% of their load will be sent to their own data center, which they have constructed for themselves. 50% of the load will be given to public cloud, just for redundant purpose. In case their data center gets burned down or explodes due to war, anything, they should not lose any data. So that's why they host 50% of the data in AWS. Almost same, it's just a replica. In a public cloud, AWS, Azure, Google, 50% of the data in their own premises. Have you ever worked on this clouds like Azure, AWS?
Yeah, I have done the I have used AWS much more than Azure, and
Hmm. Yeah.
during our college projects, we got to use that hosting applications on cloud.
Okay, then I think you have some good
Yeah,
idea about AWS.
yeah, a bit of idea there. That's
Correct.
the
So
basics.
yeah, this is one of the architectures that we are going. But in CCNA level, we will not discuss much on this deployments in cloud, public clouds, all these things. But even we are not going to focus on the spine leaf or kind of architecture. Most of the CCNA course is built on 2-tier, 3-tier network that we have seen, right? So that is what we would use it in the lab and all the topics that is going to come with the that's going to come in the CCNA syllabus. So there is another concept in addition to routing, security, switching is we would also see wireless. So before few years, wireless was not part of the CCNA routing and switching. We had different courses for different modules, CCNA 1, 2, 3, 4, different varieties, right? So now everything combined into one certificate. In CCNA, with one, if you're enrolling for CCNA, you will study CCNA security, CCNA routing switching, CCNA wireless, but at very higher level. Like you don't go in depth, just go overview of it.
Okay.
Okay. So wireless thing, we will see that in the lab. Theory would be like it won't be much interesting. It will be kind of very boring stuff like reading a uh, textbook. But we will see that wireless, even if the wireless stuff. So what would happen is in every module you would touch a wireless concept, a small theory there. So instead of looking at the theory, right, I would teach everything in a lab when we are covering a lab for wireless.
Okay.
Okay. So Mustafa, we'll see you day after tomorrow. So tomorrow I'm going out. I won't be available. So we'll see this on your Thursday evening.
ठीक है इंशाल्लाह.
Okay. Sure. Thank
ओके.
you. Bye.